so excited to be standing right here. Last year we were like, please, and they were like, no, you're not allowed. So this year we begged and we had to do some things that we didn't want to talk about, but we're here. We're actually standing inside the Network Operations Center for Quakecon. Here with Zyver, he's kind enough to bring us into the NOC and tell us a little bit about what's going on. Behind me is this stack of patch panels that they use to run all of the cable through all of this. I mean, what was it, 13 miles of cable that they ran for this? It's Cat5e. This is the core switch. It is running everything. We've got 2 fiber lines coming in for 2 gigs from AT&T. Stacks of cables. This goes out to every single table, and it's, what did you say, it was 100 and, how many ports?
100. It's 6 48-port line cards.
So you can do the math. 6 48-port line cards. I would do the math, but I'm too excited to think right now. So let's move over to the next track. This is your central infrastructure. Moving over here, we've got these 4 systems are the firewall. They're basically just, I think it's 1 for each AT&T line, and then like additional like backup internet kind of stuff. And then these things are all happy and blinking. This is running services such as DNS, DHCP. What was the other ones?
We do log stash, so your ELK stack, so you can see statistics on what's being cached, what's the hit rate like.
DHCP, DNS, and then logging and other such things, so we can pull all the statistics. So when they're talking about how we've got 70 million packets that got transferred around, what was the actual number?
I haven't looked at this year what the peak's been like. Usually it's somewhere around, tens of thousands of packets per second.
Yeah, last year I think it was like 25, I think it was 25, at peak, and that's at peak. So when everybody's in here running like crazy, we're transferring them, makes my brain hurt, 20 some odd thousand packets per second. You can figure out what that is over an hour. Make it drive you nuts. Anyway, so moving down the stack, we got this big empty space because you got to have KVM switch for all of this wonderful stuff. Actually, there's one here and then there's another one for these guys. This is the cache. So basically everything that you get on the internet, anything that's going to be like repeated hit, it's going to be cached here. We got about 2 12.5 terabytes systems. They're running 600 gig drives at 15,000 RPMs a piece. So a total of about 28.5 terabytes of caching, which isn't a lot, but it's enough to run this event. There's a lot going on here. Yep. So how do you decide what's going to be cached and what's not? I mean, obviously you're going to cache Steam stuff. What about other services like Origin or what are some of the other gaming download thingamajiggers?
Good old games. Ubisoft.
Good old games. Ubisoft.
Games. Yep. Yeah, so Squid takes the first part, and a big part of that is actually avoiding seeing all of the traffic. So it actually talks WCCP to the core to say, only send me the port 80 traffic, only what I can actually cache. Then it looks at and takes care of most of the small stuff, your JavaScript files, your little index HTML files, stuff like that. But if it sees certain URLs like Steam powered or Windows Update, it's going to say, oh, well, I have a rule that says for those, send it to Nginx. Because Nginx doesn't try to do so much statistical analysis on what the file is and how many times it's being requested. It just says, I'm going to cache this. So Nginx will then go out, do the fetch, pass it back through Squid to the client, so the client never actually knows it's going through the cache, and we don't have to tell everybody to specifically configure a cache. Then Squid keeps that copy, retains it for the entire event. The next person who comes around, they're just going to get it right out of the cache.
So what happens if something gets updated mid-event? So some random website is cached because it's been hit a lot, say techsyndicate.com was cached. What happens when it gets updated on the outside? Does it ever do a periodic check of that?
Yeah, there's definitely periodic checks. I mean, it's going to do your usual header check every once in a while, like your browser does. So I mean, you know, the browser's already doing some caching, and Squid's just got to try and be intelligent on like every 10 seconds or so. Well, if someone's requesting the site again, let me see, is there a header update? Oh, there's been one, let me grab the new stuff and pass it along. With Steam, it's like, I already know what I have, but hey, they're requesting a new chunk. So like TF2 got updated. Well, with the way Steam works, it already has all the old chunks, it'll provide that, but the new chunks, it'll go out, fetch, and then pass along to all the new clients.
Cool, so that's takes care of our caching. Now, the next part of this that I find very, very exciting is you've got 4 firewalls here. You said you got 2 of them are operating on each one for each AT&T link, which is 2 independent gigabit links from AT&T, and then you've got additional internet that's based on what the hotel provides. But what is running these firewalls? It's not. I mean, they're servers, so I'm saying they're not like Junipers. They're not. Your run-of-the-mill hardware firewall. So what is behind these firewalls? What's running these?
Yeah. So we utilize OpenBSD in part because their PF network stack works a lot better, in my opinion, compared to IP tables, especially in the configuration. Because it's an atomic change, I don't have a whole bunch of rule changes that are happening and potentially mid-event causing me to lose something. So it's an atomic change, and if I, for somehow, syntactically make something incorrect, it's going to refuse it. I won't lose my changes, but it'll tell me that, hey, your syntax is off, you need to fix that before you apply it.
Okay.
I don't usually make mistakes.
Dot all your I's and cross all your T's before we hit go on the final day. So why OpenBSD versus like FreeBSD with like pfSynth? I know it's the same, well, I say the same, but it's the same base concept from the same original stack that's been kind of forked out. Why the OpenBSD version instead of like a FreeBSD or pfSynth?
Yeah. So for me, it's because OpenBSD has continued to do certain development changes in regards to queuing. They've since replaced Alt-Q, which when FreeBSD forked their code base, Alt-Q was still kind of the basis, and it's been around for a number of years, since the FW days, which OpenBSD had to remove from the kernel because of a copyright issue. So that's why they actually wrote PF. And they've updated their queuing to perform better in their network stack. I find their queuing is very performant and a lot easier to utilize. The syntax is just much easier to work with and update in real time.
If somebody wanted to make something, obviously not this extravagant, but if somebody wanted to actually run these kind of firewalls at their house and run something similar, you would suggest them looking more into the, like, was it the OpenPF or just OpenBSD in general and using their PF stack?
I personally run that at home, and that's part of the reason why I run it here. Is I utilize OpenBSD at home, I utilize PF, and they're kind of like, they're the originators of it. And you know, a number of OSs, FreeBSD, NetBSD forked it over, even Solaris is forking it over into their operating system. So it's definitely proven to be a very high quality solution, and I like that feel of manually configuring it and maintaining it myself. I definitely appreciate having graphical interfaces as well. I just kind of prefer getting into VI and editing the config and saying, run.
He uses VI, just want to make sure we got that, because that's all right in my book. So I just want to make sure I clarify this, that you are using the PF stack that is included with OpenBSD, and you have basically built this firewall from zero up.
Yep.
You're not using like the OpenPF variation that is like this is all homegrown. You admit it yourself.
Yep.
We're here at the Network Operations Center at Quakecon. These guys behind us are actually filming us, film them, film us. It's going to be fantastic. We're going to be,
Infinity.
Yep. Thank you very much, man. I appreciate you letting us in here. We'll get back to playing some Quake. I think that's all I got. This is amazing. We're here at the Network.
The Mountain of Health.
Amazingly buff and healthy.
Even got the Pop-Tarts in there and the crown.
You see, we're a little bit healthy. There's a Coke Zero cup on the side. See, there we go. You don't have to worry about counting. Of course, they're actually
Sunglasses.
not eating us, just letting you know that. Theirs is on top of their pizza.
Oh.
It's just an illusion.
They're cheating.
Yeah, they're cheating. And we couldn't put ours on ours. They ordered lesser quality pizza from Domino's. We picked Papa John's.
Yeah.